Start looking at logarithms. Remember that you have quizzes due this week. Please check the due dates in your calendar on the course outline and make sure that you're aware that you have questions in your e-text that you can use. These questions are especially useful because there just isn't enough practice if the only thing you're doing is the quizzes. Remember what we said about logarithms last week. We had this equation, y equals log base a of x, but we said this was true if and only if x was equal to a to the power of y. So notice that in our exponential equation there, x and y have switched places. That's because logarithms and exponential equations are inverse functions of each other. And of course, we have their bases both the same. And in both cases, the base has to be greater than 0, not equal to 1. And the answer to a log is the exponent in our exponential form. We're going to look at the first 4 properties in this lecture and then look at the remaining in the next one. Log base a of 1. Think about the question that's being asked here. Remember the question asked by a logarithm. A to what power equals 1? Well, I hope you recognize that a to the power of 0 equals 1. And the answer to a log is always the exponent. So we could use this property with any kind of base. We could say log base 7 of 1 equals 0. We could use the natural logarithm of 1, which remember is log base e of 1, also equals 0. So whenever the argument is 1, the answer will be 0. What about the question for property 2? A to what power equals a? That has to be a to the power of 1. So the answer here, when the base and the argument are the same, is always 1. So some examples. Log base 5 of 5 equals 1. The natural log of e. Remember, the natural log can be rewritten as log base e, and the argument here is e. Log base e of e also equals 1. This is a good property to memorize, especially when it comes to the natural logarithm. It allows us to simplify things quickly. What question is being asked in the log for property 3? A to what power equals a to the power of r? Well, it has to be a to the power of r that equals a to the power of r. So the answer here is r. Note that when the base and the base of our exponential function inside the logarithm are the same, the answer is the exponent. So again, some examples. Log base 3 of 3 to the power of 9 will equal 9. The common log of 10 to the power of b equals b. Remember that when we have a common log, the base is 10. So the base of our log is the same as the base in the argument. We'll look at properties 4 and 5 together here and then stop this lecture. People get confused with these two, and I want you to pay attention because they're similar. Notice that we have a single log with a product in the argument. Whenever you see a single log with a product in the argument, the properties of logarithms tell us that we can write this as the sum of 2 logs. So we're going to keep the base the same and say that this is log base a of m plus log base a of n. And notice the words I'm using. When you meet with me to talk about questions that you're doing, when you're verifying tests or exams, you need to know the words log base A of m plus log base A of n. What's an example we could do here? This is a property we often use in reverse. Notice that we're starting with the sum of two logs with the same base. If I look at log base 6 of 4, and I think about the question 6 to what power equals 4, I don't know an answer to that. I don't know an answer to the second term either. 6 to what power equals 9. But if I use the property, we can write this as a single logarithm. The base stays the same, and we multiply the two arguments. So we have log base 6 of 36. I know the answer to this question. 6 to what power equals 36? 6 to the power of 2. Let's look at property 5. Again, we have a single log, but this time there's a quotient in the argument. What do you think this property is going to allow us to do? We're going to be able to write this as a difference of logarithms. The same base, log base A of m, subtract log base A of n. And again, this is a property we often use in reverse. When I think about the question being asked by each logarithm here, 4 to what power equals 32, or 4 to what power equals 8, I don't know the answer. If we use the property, we can write this as a single logarithm, the same base 4, and divide the arguments. This equals log base 4 of 4. That's our first property, or our second property rather. When the base in the log is the same as the argument, we know the answer is 1. Start looking at the homework questions in Pearson or in your e-text and get used to thinking about these properties.